To prove the identity without using the Taylor series, we must use calculus. One of the most obvious ways is to basically move this e to the I theta to the other side and letting this part become a function. So let's say that there's a function f of theta is equal to e to the negative I theta times cosine theta plus I sine of theta. Therefore, we can simply apply the derivative to both sides, so f derivative theta, function derivative of theta, and then we can also see that this resembles the form u and v. So therefore, if we take the derivative of both sides, we get that it becomes the derivative of the first, the u, times v, and then we add the derivative of v times u. So therefore, we can simply use this to our advantage. So we first find the derivative of in terms of theta of e to the negative I theta. So let's give that a small box here first. Wait. And then the derivative of e to the negative I theta is times by cosine of theta plus I sine of theta. And then we add wait. And then we add the derivative in terms of theta of cosine theta plus I sine theta times e to the negative I theta. Therefore, let's focus on the derivatives first. As we know, the derivative of d theta of e to the negative I theta, this simply resembles the form of x to the n. So the x to the n, where the derivative is just n x times n minus 1. So basically, we apply the same concept here. So therefore, this becomes negative I times e times negative I times theta. So that is the first derivative. And then for the second one, the derivative in terms of theta of cosine theta plus I sine theta. This one here, cosine theta is negative sine theta, and sine theta is equal to cosine of theta. But we need to also don't forget the I here. Okay? So now we've solved the derivatives. Let's now apply it back into our original problem. So therefore, the derivative of theta is equal to negative I times e to the negative I theta times cosine theta plus I sine theta, and then we add e to the negative I theta times negative sine theta plus I times cosine of theta. So therefore, if we simply multiply it out like this, we simply get negative I times e to the I negative theta of cosine theta plus I meant negative. Wait, since I squared is equal to negative 1, so technically negative times negative 1 is positive. So we add plus e to the negative I theta of sine theta. And then on this side, it's negative e to the negative I theta. Wait, let me get this out of the way. Of sine theta, which is then added e to the negative I theta of I cosine theta. And if we really look at the structure here, e to the negative I theta times sine theta minus e to the I theta sine theta is just 0 since it cancels out. And also if we look at this one and this one, it's the same thing. So both sides cancel out. Therefore, we find that the derivative of our original function is equal to 0. So what does this mean actually? How does it correlate to proving the identity without Taylor series? So, if the function, if the so there's a theory in functions where the function of the derivative of a function is equal to 0. That means that the function is equal to a constant, say c. And what does being a constant mean? Being a constant means that the value never changes, so it stays the same. But the constant means that the value still stays the same. So how can we find the value of the constant? So first, let's use our function first as we established in the beginning. So function of x is equal to e to the negative I theta times cosine of theta plus I times sine of theta. So therefore, let's now use the simplest f of theta. Therefore, let's use one of the simplest angles for theta. Let's use the function of 0 since we're finding the smallest value possible. So e to the negative I times 0 times cosine of 0 plus I times sine of 0. And if you still remember the tables, the trigonometric tables, we can see that function of 0 is equal to 1 times cosine of 0 is just 1 plus I times sine of 0. Sine of 0 is 0, right? So 1 plus 0. So therefore, the function of 0 is equal to 1. Hence, that means that the value of this function is the value of c is equal to 1. So therefore, we can simply apply it again. 1 is equal to e to the negative I theta cosine of theta plus I sine theta. Therefore, e to the I theta is equal to cosine of theta plus I sine of theta. And that's it.